So I will move on to Ron Kennedy and Verticon. We'll talk later, Steve. Yeah, Steve, need to follow up with you.
Sure.
Also, I have some more information that I wanted to share.
Sure. Very good. Thank you, everybody.
All right, so Ron Kennedy is with Verticon, and I think there's a lot of different Verticons, if I'm correct.
There are,
Or
but this is Verticon Defense and Security Corporation
Right.
today.
So this is Verticon Defense and Security. Ron had presented previously on the federal forum, and his solution was very pertinent then, and it's even more pertinent now. So I am going to turn this over to Ron and ask him to cover what he's doing with his floating shipyards and the Corvette. So go ahead, Ron.
Okay, I'm not seeing the screen with the PowerPoint on it. Eugene?
Yeah, I'll bring it up for you. I thought you were going to do it. No problem.
Oh, sorry.
Nope. Give me 1 second.
All right.
Just take me a minute here. So you can go ahead and talk. Introduce yourself.
Okay, well, I'm Ron Kennedy. I'm the founder of Verticon Defense and Security Corporation. We're a small business that has some very large objectives, and they have to do with the development of the shipyards of the future, and secondarily, the warships of the future. And so let me get this off the. There we go.
Can you see your presentation now?
I can. I'm not able to index it forward.
I'll have to do that for you.
Oh, okay. Well, to start with, let's go back about 60 years when the U.S. Navy was struggling to get to a 600-ship Navy. That was about the time I entered the scene and Naval ROTC program at the University of Nebraska. And ever since then, I've had an abiding interest in the United States Navy and what it's doing and what it's not doing. And so a number of years ago, myself and a few of my other stockholders became very concerned about the nature of the Navy, where it was headed, some of the threats that we talked about. And so we founded Verticon Defense and Security to deal with some of those issues. And so those are some of the things that I'd like to discuss with you this morning. Next slide, Eugene. So, and we made our initial presentation a couple of years ago. And so I went over this to see if it was still timely, and it is. And in fact, it's even more intense right now than it was a couple of years ago. So what is the status quo that we're dealing with? Well, we've got some gathering storm clouds. We've kind of got these new axis of evil with China, Russia, North Korea, and Iran. We seem to have a current dilemma in our ability to ramp up and meet some of these existential threats. Some people don't even think they're existential threats at this point. I would beg to differ with them. Back in 2014, Congress mandated a 355-ship Navy. And just within the last few months, Admiral Gilday, Chief of Naval Operations, really indicated in one of his discussions that we actually need a 500-ship Navy. Well, we're struggling to get to a 355-ship Navy, and so a 500-ship Navy was kind of surprising to us. And then the Rear Admiral Selby at the Office of Naval Research came up with the concept of small, agile, and many vessels. And since we kind of thought the way things were flowing, I think we were right. Very simple, small, autonomous, agile, attritable vessels or minimally manned vessels seem to be the direction that things are heading. And so that's kind of how we've pitched things. Next slide, Eugene. So what are the challenges currently confronting the Navy? We have a diminished U.S. industrial production capacity and, more importantly, skilled talent. I'm just a few blocks away from Naval Station Everett over here on Puget Sound, and there's a lot of vessels over there right now being maintained that are not on station, and so we have some maintenance issues with the existing vessels. We know that China is building 5 ships to R1 at this point. And they also manufacture 10 times the amount of steel that we do. So that does not bode well for accelerated building of these new warships. And we would like to pursue the doctrine of small, agile, and many, because sometimes quantity has a quality all of its own. And we do believe that. There are other overlapping doctrines that kind of coincide with that. And the doctrines of increased and distributed lethality, which seem to have they were going strong a few years ago, and now they've kind of dropped off the radar because we have some of these other existential problems that the Navy is dealing with. Next slide, please. Okay, so how do we increase production capacity? These are our objectives. We'd like to be able to do that. We want to be able to significantly improve the maintenance capacity for existing vessels. We want to provide expedited design, engineering, fabrication of new vessels. And we want to integrate this concept of small, agile, and many. And what we're talking about here is conceptually, we're talking dual use. So it doesn't make a lot of difference to us, really, whether it's a naval vessel or a commercial vessel of various kinds. We've had some discussions about building icebreakers. Strangely enough, the Arctic still has ice that needs to be broken. Russia is building new nuclear icebreakers. We have one old icebreaker, the Polar Star, that's broken down half the time. And so we think there's probably a need for some icebreakers for the Arctic. Next slide, please. So how does a small business tackle all of this? Well, what happened was I know what we do and I know what we don't do. And so what I did was I defined the areas of talent and capability that we need. And I went out into the world and identified a lot of key players. And I brought them in, I talked with them, and basically we have a core of true believers. These are all companies that believe that they're Western companies. They all believe in freedom and prosperity and self-determination. And they don't particularly like what's going on with China, Russia, Iran, and North Korea at this point. And so some of these are listed here. We have many, many others that we've added in the interim. I view myself as a conductor of an orchestra. And what I did was I went out into the world and I recruited the best musicians, so to speak, that I could find to bring to bear on all of the issues related to, building of these new shipyards, actually refurbishing of existing shipyards, and also building the ships of tomorrow, whether it's a warship or a commercial vessel. So you can see some of the folks on this slide that we have involved. Many of the companies and organizations that we have involved now are companies that are not on this slide, whose names you would recognize, that give us a global scope. We basically have the ability to access and use shipyards to build our shipyards and to build our ships, whether it's in Europe, Africa, the South Pacific, Oceania. So we really are very, very diverse in terms of the skill sets that we bring to these large projects and the talent required to do so. Next slide, please. Our proposed solutions, not surprisingly, I'm a fairly simple person, and I hear the Navy say that they need refurbished shipyards and new shipyards. So not surprisingly, we want to provide those. We hear the Navy saying that they need warships desperately and to maintain the existing ships desperately. So we want to provide that as an objective. We have taken a very hard look at logistics and supply chains overlying these efforts. And that's another reason why we are geographically distributed, because we don't want all of our eggs in one basket in one geographic location just in case. And so we've diversified geographically, and that also gives us the ability to diversify with our skill trades and things such as that. The last objective is probably starting to come on much stronger now than it was a couple, 3 or 4 years ago. And we're starting to hear Congress talk about it. And what we've tried to do is go out into the private sector and identify participants at all different levels of financial institution that we could bring together and provide what we would call an extra governmental financial system that would allow our efforts and the efforts of other defense contractors to start a project with a shorter latency, because it's financed by private sector funds primarily, and so that there's no valley of death that everybody talks about. And so that's a very, very important objective, one of our solutions that we're trying to provide. Next slide, please. So we have the concept of floating shipyards, and this is just a conceptual design. It shows basically the idea. This one has 3 floating dry docks. We'll show you one that we proposed to the Navy on a few slides down the road here. But that kind of gives you the idea of what we're talking about. So it's an overall concept. It's customized or custom designed. They exist of many modules that are designed for specific applications, different sizes of ships, different freeboards, you name it. They're all custom designed for particular applications. Next slide, please. This gives you an example of a floating shipyard that we designed for a country. We'll talk a little bit more about that later. They're modularly constructed. We can place them anywhere in protected waters. As I said earlier, they're custom designed. Obviously, we have to make sure that they're ecologically sound, so that we have to worry about wastewater and all kinds of other processes that give off caustic chemicals or coverings or whatever else. So that's foremost on our mind. A lot of the shipyards that we have quoted, the modules transit on their own bottoms. That is, there are ships in their own right. They have small crews, and so they don't need tugs. We do build them with, and you'll see this as well, with supplemental power sources. But the larger ones have all been quoted with propulsion on their own bottoms. A lot of them are capable of dynamic positioning. So if they're in protected waters in a cove or in a harbor, they will station keep within a couple 3 yards or meters and maintain station. There are thrusters strategically located that allow that to happen, as well as a lot of gyroscopic stabilization kinds of equipment on board. They are designed to function in all weather conditions. They can be certified for use by the U.S. and other navies. NATO and some of the countries over there are aware of what we're doing. Australia's aware of what we're offering as well. And they're energy sufficient for the most part. And we're taking a really hard look at the whole energy area. And so, just as a pertinent comment, what we've sort of morphed into is a private sector DARPA, because if you look at all of the attributes of a shipyard like this, it has cyber applications. It certainly has naval architecture and engineering applications. It's got defense and offensive applications, particularly if the platforms are forward deployed. I think about the coal when it was hit in Yemen, I believe it was, and they had to put it on a transfer vessel and bring it over to San Diego to be repaired. Had we had one of our vessels or one of our shipyards closer floating, they would have been able to repair it and get it back into service much more rapidly. So we're really talking about platforms of various kinds, not just shipyards. We have other applications, particularly now drones. These can be the basis for drones of various kinds. We have talked with certain entities about the idea of, if you have an F-35 vertical takeoff and landing jet and it takes off from a carrier and the carrier has damage and it can't land, that these shipyards could be alternate landing facilities and repair facilities for the F-35s. Just one of the many uses potentially for this idea. Next slide, please. Little story behind this one. This is an actual design that we had presented to the government of the Solomon Islands. And I don't know if you're aware with what's going on with the Solomon Islands right now, but what happened was the Belt and Road Initiative of China came in basically at about the same time. And this is not unusual for us because we work in many different places, and we continually run into the Chinese Belt and Road situation that we have to contend with. Well, in their infinite wisdom, the Solomon Islands decided to side with China, and I suspect that China is probably building some kind of naval facility in the Solomon Islands right now, and we're not. There are some real practical applications. This does show kind of the breadth of what can be put on these floating shipyards. It's basically it subsumes advanced manufacturing technologies and robotics, additive manufacturing, all kinds of software. You can call it artificial intelligence. To me, artificial intelligence, AI, is just somebody else's software. And so each one of these shops, each one of these applications, each one of these processes have software implications. And we heard Eric earlier today in a presentation talking about the cybersecurity. Well, cybersecurity, 25, 30 years ago, when we started using the internet for manufacturing, one of my other companies, security and safety was not even on the radar screen. And now security and safety of your online systems and everything is number one. And so we've had to react to that, as has everybody. Next slide, please. When I mentioned earlier that we had we pitched a floating shipyard here in Puget Sound. Since I've been able to see what's going on at Naval Station Everett and kind of the backlog of Arleigh Burkes over there, they've had as many as 6 or 7 in for maintenance at one time, and it's taken a long time. We thought, well, let's go ahead and propose something like this. And so this is really composed of a number of modules that would transit on their own bottoms. We could have them simultaneously manufactured in different locations and brought together in Puget Sound, reassembled like this, along with the red. In the red there, you see those are large floating dry docks. People don't realize that on the west side of the country here and in the Pacific, we're down about four large dry docks. And so we kind of wanted to supplement the existing dry docks by producing these larger dry docks. These are very large. They're 1,000 by 250 feet. And so they would accommodate your larger ships. The larger carriers might have a little problem getting in and out, but they're very large and can accommodate very large ships. And this could be located in Puget Sound, and it could be geostationary. It could be tethered as well. Each of the modules would have their own power supply. We're taking a look at some small nuclear power plants right now that may work, but there's all kinds of other, let's say, green energy that we're looking at too. And of course, in Puget Sound, we have to be very careful about all the ecology that we would have to be mindful of. Next slide, please.
All right, so Ron, I'm going to interrupt you here for a second.
Yeah, go ahead.
So, and I haven't looked at the deck, but are you going to talk about the benefits of the fact that you're not using up shoreline resources, you're not using up land, so these could easily be brought to augment existing shipyards?
Yes, that's one of the more obvious uses for these. They still require some interface with the shore.
Right.
You're going to have shuttles with materials and manpower coming aboard. The larger ones like this would have their own facilities, dormitories, things like that would sustain your workforce. Would be manned probably on and off for several months at a time by different crews, much like ships would be.
Yeah, but what I'm saying is you don't need land assets to augment a shipyard as well.
No, and that's one of the
out into the water.
Right, and one of the issues with Puget Sound is that there are very few shoreside locations that something like this could be built. And the permitting and all of the green hoops that would have to be jumped in order to put something like this on the shore would tie things up. I might add that when we did this, and it's even more critical now, one of the people that we made the previous presentation to said, Ron, what would happen if we went to war tomorrow? That was the question. And so what we tried to do is go out into the world and figure out how to be able to do these things in some kind of compressed time frame. And we don't have time for 10 years of permitting. That's unacceptable. and we do know that doing it on the sound is less heinous, but there's still a lot of permitting hoops that would have to be jumped that would slow things down. There are other places where that may not be true. We're looking at potential locations on the Missouri River that might be able to accommodate a floating shipyard or a shoreside shipyard with floating assets. Same way on the Ohio River, on the eastern edge of Kentucky. And everybody says, well, that's kind of crazy, except that those things could happen much more quickly and are not so hung up in the red tape that we see out here in Puget Sound. So there's many advantages to doing it on a floating basis as opposed to having it directly tied to the land. Particularly if you take a look at the time frame that we've been told by people in the know that we have to be aware of. I don't see that sense of urgency in a lot of the procurement processes, by the way, just kind of as an aside, and that does provide some frustrations to us at this point. It may take some very major situation, God forbid, for things to be allowed to speed up. But right now we're way behind the power curve on both the building of ships as well as the refurbishing of existing shipyards and certainly new shipyards. As I say, China is pretty much beating us to the punch on every front there. And qualitatively, perhaps their ships aren't quite as good as ours, but if they can produce 5 times as many in the same length of time, then again, quantity has a quality all of its own. And there's a significant time crunch that we're talking about here that people just seem to be oblivious of. Well, we're not. We understand the time crunch. And that's one of the reasons why we did the modular situation with the company. We went out and so that we can simultaneously build these things in different places and bring the modules together and construct whatever configuration of shipyard is required. We think, and we're starting to see more people thinking about this, but it's still a big hurdle to overcome, I think. If I had a bolt that we had invented new metallurgy for that wouldn't corrode and didn't need to be replaced on ships, I think we probably could have, been a long way down the road toward actualizing that bolt. We're talking about an elephant here, and the DoD and Congress and others, the Navy, are having a difficult time, I think, getting their head around what our capabilities really are. So, okay, when I mentioned that we have the ability to move platforms around without them being on their own bottoms, without their own propulsion, we have one of our participant companies, DTG Propulsion from the Netherlands, that provides these large outboard motor type assemblies that can be attached to the outside. You can also use tugs, but if you want to be able to move it around and station keep, then it's handy to have these kinds of thrusters associated with a platform. Next slide, please. One of the things that we've taken a hard look at is containerizing the workshops. As you saw on that one slide that we did for the Solomon Islands, there was 8 or 10 workshops. Well, these can all be containerized in a single or multiple cargo containers, and can be that would expedite the placement of them on the platforms for the smaller platforms. Certainly not the larger ones. So I kind of discount that one photograph up there where they're working on the rudder. That kind of a platform would be probably not something that we would do because typically there'd be more aspects to it than working on something there. You don't dry dock a ship to work on one small thing. So, but nonetheless, the workshops are all modular for the smaller platforms, and that expedites our ability to bring these on station for our warfighters very rapidly. Next slide. So the operating philosophy is basically a merger of all technologies that are appropriate. You know, whether we're talking about artificial intelligence, we're talking about advanced manufacturing technologies, digital twinning. We do have the ability right now to design a ship and build it virtually, and give people a headset and allow them to actually walk around the ship and stand on the bridge and look at the placement of all of the instruments and electronics, and provide input as to where things should go. So the idea of using the latest technology, whether it's materials or cyber or AI or advanced manufacturing technologies, 24-hour dark factories, those are all things that we're looking at. We've got a strong effort going right now in robotics. You see that robot down at the right-hand corner there. We have a number of robotics companies that we have worked with or talked with regarding how one might design robotic work cells to design ships, to build ships. And there's been a tremendous amount of work done in that area now. And we think that you can probably replace, there's a problem with welders. Well, you can robotically weld probably about 80% of a ship if you're using the right kind of robotic welding. But that means that you have to be able to manipulate the ship module that you're building as well. And so how do you do that? Well, we've got some ideas about how you start with small modules and then up to maybe 150 or 200 tons. And then you can manipulate them, robotically build them, robotically weld them, robotically coat them, and then join them. And so that's an effort that we've got some talented folks taking a real hard look at this point. So the operating philosophy is completely different than the old. Our shipyards are 100 years old, and there's just so much new technology that we want to bring to bear. Next slide, please.
All right, I got a question.
Yeah.
Made your best. Go ahead.
Hey, sorry. So I was wondering, did the Baltimore situation where the bridge was kind of collapsed, was there an opportunity there to kind of showcase your ability? Over.
Honestly, we've been talking to so many people about so many shipyards in so many places that really has not even gotten on our radar screen. We were working on 4 potential projects in the Horn of Africa, Djibouti, Somalia, Yemen, one other, for major infrastructure projects dealing with these floating shipyards and other things. That everything came to a screeching halt, obviously, when the war started over there. So we're kind of re-looking at things like that. But no, directly to answer your question, nothing to do with Baltimore at this point. No.
Thank you.
Mm-hmm. Next slide,
Right,
Eugene.
Well, no, there's another question. So Carolyn,
Oh.
Can you unmute and ask your question?
Yes. I normally don't speak up at these things, but I was
Hi,
just
Carolyn.
curious. There's a lot of there's a lot of focus in the DoD's CIO, in the DoD wide, as far as electronic protection goes. Do these types of ships, shipyards, dry docks, modular units offer any sort of like electronic protection measures such as shielding, MCON, reduced cross section, things like that?
Yes.
Yeah.
All of the above. And it's both defensive, everything that we can do to protect, as for an example, forward deployed shipyards. You know, they're going to be attacked one way or another, whether it's cyber or kinetic. So we've got to be mindful of that. But I'm kind of an offensive guy. I kind of like offense. And so the question is, can we use these platforms in any way, shape, or form for offense? Can they be, and we just saw over not too many days ago, Arleigh Burke, I think it was, that shot an SM-3 missile and hit a ballistic missile. Maybe several ballistic missiles were taken down by the SM-3. These shipyards could have kinetic protection, could have kinetic offensive capability, as well as defensive capability. Will they have close-in weapon systems, rolling rail missiles and such? phalanx.
So-
You bet. You bet.
Are you
So-
looking, Carolyn, were you looking more
I-
at topside signature type protection?
So all of that. So like,
Yes,
Um,
stealth.
I get-
Yeah, we're looking at radar absorbing materials, all kinds of, there's new armor that might be brought to bear. There's new concrete that has certain characteristics that might be good for the decking that are also radar absorbent. There's new coatings that we're looking at. The shape, certainly we're aware of. We do have folks that are heavily into aviation and stealth and those kinds of things. So stealth, as it applies to our output, is certainly top of my brain as well. So all of those technologies. That's why I made the comment earlier that we're kind of a private sector DARPA, because we've gone out and we're trying to evaluate all of these things kind of on the fly. And that's the technology. The art, it seems to me, is how you integrate on the fly all of this new technology. You don't want it to be too early because it might not work. So, when we build a ship and we sign off to build a ship, the ship that we sign off on to build today, because of the compression of technology within time, technology is accelerating per unit time. How do you integrate all of these new technologies into your output on the fly? And that's the art.
But, and I understand that. But specifically, as you've mentioned, especially China and its growing rate, they're already outmatching us with, they're already outdoing us, and especially electronic attack methodology.
Mhm.
So are you looking at threat countries or potential threat countries, their electronic attack capabilities, and then building your systems to be able to defeat what they have out there for electronic attack? And that's what I mean by electronic protection. Because like I said, there's technology being built, there's a lot of things being built, but it seems to not be able to operate very well in a heavily congested and contested electromagnetic operation environment. So the the EMOE, over.
I can hear you.
Yeah, no, I didn't catch that last part, Carolyn.
So basically, I was just curious how, if you're using knowledge of threat countries' ability to electronically attack, especially the United States and where we are, because we're so far behind the power curve with electronic attack and electronic protection measures, are you looking to build that in up front with what you're building? Like, how do we?
Yeah, the
protect
answer to
them?
that is yes. And
Yeah.
At this point, on a more or less public presentation, I really can't go into a lot of the detail with some of the concepts and technologies that we're looking at right now. But to suffice to say that the answer to that question is yes.
Thank you.
Yeah,
I
and
appreciate that.
I guess too, it would have a lot to do with where it is. I mean, if you're going to put this in Puget Sound or in the Chesapeake Bay, you're not going to need those. But if you're going to put it in Taiwan or Japan, then they may be
Or Guam.
Yeah, or Guam, exactly.
I
Yeah,
argue
or
that-
Guam.
Yeah, Subic Bay. Yeah.
Yeah.
I
they
argue
would
that
be-
it's needed no matter where it goes. But
I think that's a conservative. We're very conservative. We try to look at the worst case scenario and try to prepare for the worst case scenario, whether it happens or not. And so the answer to your question is yes. We're looking at kinetic means of protecting our platforms. We're also looking at non-kinetic means of protecting our platforms. Generally speaking, those are the two areas, but there's a lot of specifics within each of those areas that we're looking at applying.
copy. Thank you. Appreciate your
Mhm.
answer.
Thanks for your question.
Yeah, so Carolyn, if you wouldn't mind emailing me, I don't know if you want to put your contact information in the chat, but if you could email me after this, and I'd like to have a more in-depth discussion about this.
Will
Next
do.
slide, Eugene.
Okay, well, Major Best, did you have another question, or is
Oh,
your hand just
sorry.
still up?
Oh, sorry, no, sir, my hand's still up, sorry.
All right, go ahead.
Okay.
Go ahead, Ron.
All right. So conceptually, we've been talking about shipyards, but the question is, if we had a shipyard, what kind of a ship would it build? And so we've gone ahead, and this is all on our own nickel, by the way. We've funded all of this privately. We have developed a really nasty, this particular one we'd call a Variant 1 Corvette, and it's designed around the concept of small, agile, and many, and the concepts of distributed lethality. Next slide, please.
We're down to about 10 minutes.
Okay, and so what we've done is we've had a number of design considerations, and again, it has to do with all of the technologies that we're building into these ships. So we're looking at modular construction, moderate displacement, more heavily armed than a typical ship would be, a typical Corvette. Conventional propulsion because it's simple and everybody understands it. Fleet-proven systems so that things don't go wrong, like on the LCSs. Really multi-mission capable with modular weapons loadouts. Heavily offensive, which will become more obvious as we go through the slides here. Designed around a new vertical launch system, not the Mark 41s, but the Mark 57s that handle all of the new missiles that are coming down the pike. And it has a long range and capable of dwelling for a long period of time. Next slide, please. There's a lot of additional design considerations. Primarily, what we wanted to do was design a ship because, as NATO has told us, 50% of the Corvettes in NATO are going to be decommissioned within the next 5 years. You know, they're looking for alternatives. So what we've done is we've tried to take that into consideration from a timing standpoint as well as a design standpoint, and provide them with a multi-use ship that is lethal enough where our enemies are going to have to pay attention to it or to these ships, and they will not operate. And this speaks a bit to the doctrine. We don't believe these will operate with the carrier groups. They're not designed to operate with the carrier battle groups. They are lethal enough in quantity that they're going to have to be accounted for by the enemy and draw fire away from the carrier battle groups. So I'm assuming, Eugene, that these slides are going to be available for people to take a look at, and we're trying to cover a lot here. So that's generally the concept that we're talking about. Very, very nasty, aggressive, offensively oriented, but very flexible, smaller vessels that you can mass produce. Next slide. And we go through this pretty quickly. We put this here so that if anybody really wants to look at the specific specifications of this particular vessel, this one has 12 VLSs on board. We have a variant 2 that has a 50-foot insert that allows for another 12 to 16 vertical launch systems, and it still maintains the helicopter pad at the rear. So that would be about 350 feet and displace about 2,200 tons. So you can look at those. We've done a lot of testing on this already. Go to the next slide and we can talk about that. Well, let's really quickly, the armament. There's the Mark 57 vertical launch systems on the foredeck there. We've got torpedoes. We've got the deck cannon, just in case somebody tries to get too close. We've got two close-in weapon systems, the CRAM, which is the rolling rail. We've got two phalanx close-in weapon systems. We have one large MH-60R helicopter that can be used in anti-submarine or whatever. And on this particular iteration, we've got two 38-foot high-speed interceptor patrol vessels that could be deployed to handle terrorist vessels in the vicinity. Next slide. We have done considerable engineering on this. We have designed the hull. We have used the supercomputer up at Ohio State University to run the iterations of this. And so you can kind of see the pattern that we used. You can see the underside of the vessel. And if you would go to the next slide, you can kind of see what it looks like. Skip that slide. You can look at that. It basically says that this is a long-legged ship and it doesn't use a lot of fuel. It uses four low-speed diesel engines that are very simple, very straightforward through Wärtsilä gearboxes. And but what you get is and you run iterations of a full hull load, a full displacement at the various speeds, and then you can see just exactly what kind of stresses and strains there are in the hull, and a little bit of what the waveform looks like, which has a lot to do with the efficiency of the vessel. Having the bulbous bow, we tried it without the bulbous bow. We put a bulbous bow on it, and it was 18% more efficient. Used 18% less fuel, and got 18% better mileage. And so, the bulbous bow makes some sense. Next slide, please. And again, we ran it all the way up to, the final design considerations. And this price kind of depends on what the vessel is meant to do.
To slide up?
Yeah, that's fine.
Okay.
And and again, referring to the lethality, we want it to be lethal enough where an enemy has to pay attention to these vessels away from the carrier battle squadrons. That's kind of the doctrine. We don't want these with the carrier battle groups. We want them away. I'll give you an example. If we had these 3 or 4 of these variants off North Korea, and they had the SM-3s in them, the anti-ballistic missiles, then 3 or 4 of our ships could take care of all of the ballistic missiles coming out of North Korea, and they wouldn't be around a battle group. They would be located elsewhere. Okay, next slide. We just put this in. If one of our shipyards, it would take us 5 years to get an operational shipyard. If we did it sequentially, we can really, I think, reduce the time for building both the shipyards and the ships by using simultaneous locations to build out the modules. But I wanted to show kind of a worst case here for both of them because we had been asked for that before. Next slide, please. So in summation, I looked at what the Navy needed. The Navy purports to need shipyards. And so we said, we'll build you your shipyards. They need refurbished shipyards. So we said, we'll refurbish the shipyards. And they need ships. And the niches, the large ships, the carriers, the cruisers, the frigates, those are already taken. That there are large defense contractors doing those. We would like an opportunity to work on the small, agile, and mini, and build out those types of vessels. And overlying this, we still are working very hard to come up with this extra governmental financial system that we and other small defense contractors can use to finance their projects and not have to worry about starting and stopping with the vagaries of the congressional budgeting process. I think that pretty well sums it up conceptually. Very much thank you for your time, and I'm available at any time through our website at verticondefense.com or through Eugene. So I really appreciate the opportunity to speak to you, and if you have any questions, I'd be more than happy to take them.
Thank you, Ron. So let's open it up for questions. Does anybody have anything for Ron on either of the opportunities he discussed? Brian? Yeah, I know you want. I was waiting for you, Brian.
Hi, Brian.
Let's talk about basalt.
I'm so
man.
excited. I listened
You look excited.
every word you spoke. I'm just passionate about this topic.
What's your background?
I work with water piercing ballistic ammunition
Okay.
and fusion energy. And then for the last few years, I've been working on high strength concrete, volcanic basalt minerals, and I could help you almost in every spectrum on your project here. I'm pretty excited. I'll shoot you an email.
Okay, that sounds great.
And-
We're open
and-
to all of that.
And for Carolyn, this is one of the reasons I wanted you to send me an email. I wanted to put you in contact with Brian because I think you might be intrigued by what basalt fibers can do.
We're interested in new materials.
And just yesterday, it looks like we're going to try, I'm working with Nick, we're going to try and get basalt listed as a strategic mineral through the Defense Industrial Based Consortium.
Do we
Where
have
they're
a
trying to
supply?
classify. Yeah, they're going to try and classify basalt as a critical resource to build ships, bridges, concrete structures, power plants, and electronic circuitry boards.
Okay. Yeah, we have an interest in all of those niches.
Yeah, the goal here is to have Brian and Nick do multiple presentations because the basalt applies to firefighting, to anti-ballistic properties, construction, and the list goes on and on and on.
Mhm.
I know of at least 25 applications. So
And then just yesterday, it looks like Nick's company just purchased AIT Composites in New England, and they build composite bridge spans, which could work very well with your dry dock situation.
yeah,
Absolutely. Absolutely. Yeah, we're open to all of those kinds of new materials and new construction processes.
that's great. Yeah, no, I was waiting. I was going to bring you in. Okay, anybody else? All right. Well, we're 3 minutes past. Well, thank you, Ron. I
Okay,
appreciate it.
Eugene, thanks for the opportunity. Appreciate it.
Yeah. So the videos will be up on YouTube, our YouTube channel by Monday, close of business. It just depends on how long it takes for the editing process, and people can see them there. They're also uploaded to our document repository, which is accessible through the website, and the presentations will be there as well. Or you can email me directly to get copies of the presentations. But the videos aren't downloadable from. I should turn on my camera while I'm talking. The videos aren't downloadable from YouTube. That's why we put them up on the document repository. That way, especially federal people, they can't stream live when they're sitting at work, so they're able to download it and then watch it offline that way. All right. So thanks again. Thanks for your attendance. And like I said in the beginning, the success has been tremendous. We're having to shift to a biweekly forum so that we can catch up. And once we do that, we will be back on to a weekly schedule. So if nobody has anything else, I'll go ahead and wrap it up here.
Thank you, Eugene.
Thank you. You take care. Good talking with
You
you again.
too. Yep.